What is the scale of the map? How do I use the scale of the map? Good morning, everyone. This is Rawana Hara with Junior Certificate Mathematics lesson. And the topic of today is the scale of the map. The lesson objectives says, by the end of this lesson, you should be in position to solve problems involving the scale of the map. But then, we need to understand what the scale of the map is. The scale of the map simply refers to the relationship between distance on the map and the corresponding distance on the ground. For an example, you can have a situation where the scale of the map is 1:100. So here we are simply saying 1 centimeter on paper is equals to 100 meters, rather 100 centimeters on the ground. So the scale of the map is a statement of equivalence. This is what this statement is simply saying. And then it goes on and says, a scale is a ratio which shows the relationship between a length of drawing on paper and the actual distance on the ground. So this is what the scale of the map is all about. But before we develop further on this topic, let me invite Tumisang, a learner from Pitikwe, to join me in today's discussion.
Good day, everyone. Good explanation, Mr. Har. I really enjoyed it. Before you make a scale drawing of a real life, I guess you must convert the measurements using a scale. What are some of the important metric equivalents one is expected to know?
Thank you, Tumisang. You are saying I should discuss the conversion factors. Let us look at the conversion factors before we go further. The matrix conversion says, this is what you are expected to know. The metric equivalent says 1 kilometer is equivalent to 1,000 meters. That is, for every 1 kilometer, then you should know that 1 kilometer will give you 1,000 meters. And then 1 meter is equivalent to 100 centimeters. Then 1 centimeter is equivalent to 10 millimeters. You need to know these conversion factors because we'll be using them as we'll be solving our problems. Let me also invite you again to chip in and say something with regard to today's topic.
I'm just wondering about the representation of the scales. How do you represent scales?
A map scale can be represented in weights. It can be represented as ratios or as fractions. Now, let us have an example to see how all this can be done. We've got an example here. It says 1 centimeter to 100 meters. This statement is given in weights. So the scale of the map here is represented in weights. You are now to represent this in, say, because we are saying the scale of the map can be represented as weights, ratios, or fractions. So the statement is given in weights. Now let us represent the statement in ratios and then fractions. Let us represent this in ratios and then fractions. 1 centimeter to 100 meters. Now, in ratios, what will this be? Let us start with ratios. In ratios, 1 centimeter to 100 meters. 1 centimeter to 100 meters. This is not yet the scale of the map. We can see we got the units here in centimeters and then here in meters. So we can't say this is the scale of the map. It's not simplified. For us to say it is the scale of the map, it has to be simplified. The units need to be the same. So we need to convert the meters into the centimeters. And remember our conversion unit. Our conversion unit simply says 1 meter is equivalent to 100 centimeters. So we'll have to change this 100 meters into centimeters. Now this will be 1 centimeter is to 100. And then we need to multiply this by 100 because we said 1 meter is equivalent to 100 centimeters. So we have to multiply by 100 centimeters to change the meters into the centimeters. Now we have 1 centimeter is to 100 times 100. And then this will be 1 centimeter is to 100 times 100 is 10,000. Is to 10,000 This is 10,000 centimeters. Now we got the centimeters here and then the centimeters. So the units are the same. This will then be, this will be 1:10,000. 1:10,000. So this is the scale of the map. 1 centimeter on paper represents 10,000 centimeters on the ground. So this is the scale of the map and it's represented as ratios. Now, how do we represent this as fractions? When we represent this as fractions, this will be as fractions now. As fractions, it will be 1 divided by the 10,000. It's 1 divided by 10,000. This is supposed to be a 0 and then this is a 0 as well. This is a 0. So this is how we represent map scales. You see that's represented in weights, where you can be given the statement in weights and then you have to represent it as a ratio or as a fraction. We managed to represent the given statement in ratios and then as fractions. Let us have a look at another statement. 1 centimeter to 1 kilometer. 1 centimeter to 1 kilometer. This will be 1 centimeter to 1 times 1,000. When we multiply by 1,000, you are now changing the kilometer to the meters. And then go on and change this to the centimeters. Up to here, you have changed to the meters. Now, you want the units to be the same. That means you have to go on and multiply by 100 centimeters. This will be 1 centimeter is to 1, 2, 3, 1, 2 centimeters. And then this simply says 1 is to 100,000. 100 is to 100,000. 1 is to 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 centimeters. So this simply says 1 is to 100,000. So this is the scale of the map. It has been represented as a ratio now. Now how do you represent it as a fraction? Now this is a fraction. The fraction format of this will be one divided by 1, 2, 3, 4, 5. So it has been represented as a fraction. 1 is to 100,000 as a ratio, and then as a fraction it's 1 divided by 100,000. It has been represented as a fraction. Now remember, the representation of scale map can either be in weights, as a fraction, or as a ratio. Remember, we are still discussing the scale of the map. Let me invite you to ask another question regarding the scale of the map.
Thank you, sir, for what you have discussed so far. Another thing is when you are given the scale of a map and then expected to find the distance on the map or even the actual distance. How do you work this one out?
In the given example, it says the scale of the map is 1 is to 5 million. So we are to find out what the distance on paper will be. That will equate to 490 kilometers on the ground. So let us start by converting 490 kilometers to the centimeters. 490 kilometers will be equals to 490 times 1,000. Remember, when you multiply by 1,000, you are now changing the 490 to meters. But you want to change to the centimeters, so you have to multiply by a further 100. centimeters. This then will be 490. Then how many zeros do we have on this side? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 centimeters now. So 490 kilometers, it's equals to 490,000,000 centimeters. So we are to use this distance now to find what this will equate to on paper. Remember, the scale of the map is 1:5 million. 1, 2, 3. 1, 2, 3. And then the distance that we are to calculate its equivalence on paper is 490, then 0,000. So this will be 4, 9. Then how many zeros after the 9? 1, 2, 3. It's 49 million. 1, 2, 3. 1, 2, 3. So we are saying now we need to know what 49 million will be on paper. So this will be X. This simply says this will be 49 million. This is supposed to be 49 million. 49 million divided by the 5 million. 5 million. One, two, three, four, 5. 5 million. Then there's the last 0 here. Then this 0 cancels this. This 1 will cancel this. This 0 will cancel this 1. This will cancel this 0. This 1 will cancel this, and this. Now, what you are simply saying is your X is equals to 49 divided by 5. This will be equals to 9.8. 9.8 centimeters. What does this mean? This is simply saying 490 kilometers on the ground. It's equivalent to 9.8 centimeters on paper using the scale 1:5 million. That's how you convert distance on the ground to distance on paper. Now let us have a look at another example. It says the scale of a house plan is 1:100. On the plan, the length of a room is 6 centimeters. Find its true length. So the true length, this is simply distance on the ground. And then let us have a look at the scale of the map. It's 1:100. And then it says find on the plan the length of a room is 6 centimeters. So the 6 centimeters will be this side. Find its true length. The scale of the map is 1:100, and then it says what will 6 centimeters on paper represent on the ground. Then this will be y. Just use a variable y. Then this will be 6 multiplying 100 will be equals to 1 times, it's 1 times y. Okay. 1 times y is equals to 6 times 100. And then this will be 1 times y is y. This will be 600 centimeters. 600 centimeters. When we get this as 600 centimeters, it says find its true length. That is the distance on the ground. You cannot leave your answer as 600. You can't leave it as 600 centimeters because you are looking for the distance on the ground. Now, distance on the ground should be represented in meters or kilometers. Now, here is 600 centimeters, meaning we can convert this to the meters. Therefore, the distance on the ground will be y equals to 6 meters. Where do we get the 6 meters from? 6 meters. We are simply dividing 600 centimeters by 100. Remember, 100 centimeters is equals to 1 meter. So we are simply dividing 600 by 100 to get the 6 meters. This is how you convert between distance on the ground and distance on the map. Let us go for a short break. When we come back, we'll continue with our lesson. Let us move to the next question. And probably let me invite Tumisang to chip in and help in this discussion.
I have been listening to you, sir, and I enjoyed your lesson. I, however, realized that you've only discussed the linear scales. What about the area scales? Can you please present an example on area scales?
The question here with me will help you understand the area scales. It says area scales. Find the area scale if the linear scale is 1:100. So 1:100 is a linear scale. Now what about the area scale? Remember, when we talk about area, you multiply 2 dimensions. Now, even when you talk about the linear scales, for you to find the area scales, you multiply the linear scales. For instance, the scale here is 1:100. Now how will you find the area scale? This will be 1 squared is to 100 squared. When we deal with the area scales, you square the linear scales. So this will be 1:100 squared. This simply means 100 times 100. Remember, 1 squared also is 1 times 1. And then 1 times 1 is 1. Then what about 100 times 100? 100 times 100 is 1, 0, 1, 2, 3. So 100 squared is 10,000. So the linear scale is 1:100. The area scale will be 1:10,000. This is the linear scale. This is how you find the linear scale. You simply multiply the linear scale by itself. Let us go on and work out a question involving the area scale. It says the scale of a map is 1:200. What area does 8 centimeters squared represent? Remember, you are given the scale as a linear scale. So you need to convert this linear scale into an area scale. And then how do you convert a linear scale into an area scale? You multiply the linear scale by itself. So this will be 1:200. And then square this. Square this side as well. So this will be 1:200 squared. This simply means 200 times 200. 200 times 200. We can work it out here. 200 times 200. 0, 0, 0, 0. Then 4. 2 times 2 is 4. So it's 1:40,000. This is the area scale. This is the area scale. It will be 1:40,000. Right. So the linear scale 1:200. Its area scale is 1:40,000. That's when now you can work out the question. The question says, what area does 8 centimeters squared represent? These are in centimeters. So the 8 centimeters will be here. Another one. Then what about here? Will be x or y or any other variable. So 8 is to x. You are now trying to work out what 8 centimeters on paper will represent on the ground. So this will be 1 times x is equals to 40,000 times 8. It's not 4,000 but 40,000. 40,000. 1, 2. 40,000 times 8. And then what will we get? 1 times x is x. And then 4 times 8 is 32. And then how many zeros? 1, 2, 3, 4. 1, 2, 3, 4. So we are simply saying 8 centimeters on paper, 8 centimeters squared on paper will represent 320,000 centimeters squared on the ground. Remember, the units, these are the centimeters. Now, how do you convert this to the meters? Because you can't leave the answer as the centimeters squared. Remember, 1 meter is equivalent to 100 centimeters. Now, when you square this side, you have to square this side as well. So, this will be squared. So what you are simply saying is 1 meters, not centimeters, but meters. 1 meter squared, it's equals to 1, 0, 0, 0, 1, 2, 3, 4. It's 100 squared. That will be 100 times 100 is 10,000. Then this will be the centimeters squared. So in short, we are simply saying 1 meter squared is equivalent to 10,000 centimeters squared. And then now, you are to represent your answer there in the meters squared. So you had your x as x is equals to 3, 2, 0, 1, 2, 3 centimeters squared. Divide this by 10,000 centimeters squared because you want to change to the meters squared. So this will be divided by 10,000. And then this 0 cancels this one cancels this 0 cancels this one, then this one, this. So the x will be equals to 32 meters. It's 32 meters squared. 32 meters squared. This is the answer. So what we are simply saying is, we are simply saying 8 centimeters squared on paper is equivalent to 32 meters squared on the ground. Let us have a look at the last example before we wrap this lesson. It says the scale of a map is 1:1,000. What is the area in centimeters squared on the map of area 5,000 meters squared? So let us convert the linear scale 1:1,000 into area scale 1:1,000. Need to square this to change to the area scale. Square this. And then 1 will be to 1 million. When you multiply 1,000 times 1,000, you get 1 million. So this will be 1 million. And then it says 5,000 meters squared. We have to change this 5,000 meters squared into centimeters squared. To change the 5,000 meters squared into centimeters squared, we have to multiply the 5,000 times 10,000. Remember, 1 centimeter squared is equivalent to 10,000 meters squared. So we have to multiply by the 10,000 centimeters squared there. Then this will be not y, but rather we're still converting between the 5,000 and the centimeters there. So that's not equals to y. So this part here will be equals to 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So there will be 7 zeros after the 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. Now, the 5,000 meters squared is equals to 1, 2, 3, 4, 5 centimeters squared. We now managed to change this into the centimeters squared. We now go back to the question and then answer it. 1 is to 1 million. 1, 2, 3, 4, 5, 6. This is a 0. 1 is to 1 million. And then what we have on this side, it's 5. Then how many zeros? 1, 2, 3, 4, 5, 6, 7. 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then this will be a variable y. Then multiply 1 million times y, it's 1 million y. Then 1 times 5, 0, 0, 0, 0, 0, 0, 0. This will be y, it's equals to 5, 1, 2, 3, 4, 5, 6, 7. Check if at all the zeros tally with what we have at the top there. Then divide by 1 million as well. 1 million. 1, 2, 3. This is a 0. This is another 0. This is a division sign. 1, 2, 3. Now you can start cancelling the zeros. 1, 2. Then this one cancels this. This 0 cancels this 0. This one cancels this. And then this one cancels this. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Good. Now we are simply saying y is equals to 50 centimeters squared. This is simply saying 5,000 meters squared on the ground is equivalent to 50 centimeters squared on paper. Remember, the lesson objective said solving problems involving the scale of the map. So we managed to solve problems involving the linear measurements, where the scale is given as a linear measurement and then also as an area scale. Remember, every time you need to make sure that when you want to convert from linear measurement to the area scale, you square the linear measurement. We have now come to the end of this lesson, and I want to believe you have enjoyed this lesson. Keep revising the scale of the map. Till we meet again, thank you.